So to recap what we saw earlier, the joint equation of a pair of lines through origin is always a second degree homogeneous equation in x and y, and conversely, a second degree homogeneous equation in x and y always represents a pair of lines through origin. Right? Now based on the homogeneous equation in x and y and of second degree, we can find out what is the nature of the lines involved in that pair. So if the quantity h square minus ab, okay, that appears in the equation is greater than 0, then the lines are real and distinct, because if we see the proof that we did earlier, the h square minus ab is the term that appears inside the square root. Okay, so if it is greater than 0, the lines are real and distinct. If h square minus ab is equal to 0, then the lines are real and coincident. So that corresponds to real and equal roots of a quadratic equation. And lastly, if h square minus ab is less than 0, then the lines are not real, simply because the slopes themselves will not be the real quantities. Now based on this, we can solve the questions of joint equation. Find the separate equations of the two lines whose joint equation is 3x square minus 10xy plus 3y square equal to 0. Now if you remember, if we were given two separate equations, then we just multiply them to get a joint equation. So here, if the joint equation is given, we try to of course factorize or break them into two separate equations. So looking at the terms here, 3 minus 10 and 3, we clearly identify that they can be factorized. So it gives us 3x square minus 9xy minus xy plus 3y square is equal to 0. So therefore, taking 3x common, we have x minus 3y, and then taking minus y common, we have again x minus 3y equal to 0. So therefore x minus 3y and 3x minus y equal to 0. So therefore that implies the individual equations are x minus 3y is equal to 0 and 3x minus y equal to 0. So these are the separate equations of the two lines whose joint equation is given to us.